go ahead and get started. I'm pleased to see that people think this is an important problem. There's a mic? It's on the podium. Yeah. So if I use my lecture voice, is that adequate, or do I need to use the mic?
For the live stream.
I'm recording though.
Yeah. Okay, so thanks for coming to the session. My name is Andrew Grimshaw. We're here to talk about, and this is a BoF, not a panel. And what a BoF to me, the difference between a BoF and a panel to me means at some point we expect some audience participation. And so there's a number of us here. I tried to select the people for the BoF that sort of represented different perspectives. Andrew Chien, because he's been sort of into this whole renewables for computing for quite some time, and he had a session last year on this. He'll be our first speaker. I also invited Sill. He provides sort of our company's building in the Texas West Load Zone, where it's the vast majority of power is renewable, and I wanted to get sort of a local flavor on that. I wanted to have both Europe and Asia represented because in the United States we tend to have a fairly narrow perspective of things like carbon and energy costs. So I invited Kranzlmüller from the LRZ in Germany, and Satoshi Matsuoka from RIKEN, and Vincent from the National Supercomputing Center in Singapore. Singapore itself has some very unique situations that it's facing right now, and I thought that would be a good perspective. And then I invited Jay because I've known Jay forever, but also because he sort of represents a bigger industrial perspective than a lot of us. So, like I said, what we're going to do is our basic agenda is this. The top is a quote from Jack Dongar. I thought I would put that up there because probably at least half the people here saw Jack's talk this morning. His perspective is, that as a community we have to address some of the power and carbon footprint issues of what we're doing. So, from my perspective, the agenda is I'm telling you the objective. We've done some introductions. Then for each of us, we're going to do 1 to 2 minutes. I've told them at most 1 slide or no slides. And several of the guests here have decided to have no slides because they're just giving their perspective. That should get us 10 to 12 minutes into the BoF, maybe 15. Hopefully I won't have to get a hook out and pull anybody in. Then what we're going to do is go to audience participation. And what I'd like people to do is to either ask questions of the panelists, make position statements of their own, and then discuss, right? And during that discussion, I have 2 things. We are recording this I don't know what we're going to do with recording, actually. So if you don't want to say something that might get recorded, don't say it, okay? And then we'll also be trying to keep a text version of what's going on. And so somebody's going to come up here once we're all done with that and be busily hammering away with the questions and what we thought the responses were. I'm a big believer in recording. I'm a big believer in writing things down. So that's what we're going to do. And so without further ado, what we're going to do is we're going to start with Andrew Chien. And Andrew, do you want me to flip the slides forward, or do you want to do it?
There's only one, so.
Yeah, exactly. I made sure of that.
Oh, go back, and I'll just give the context.
Right, and anybody who does come back here, be careful of this cable, because we don't want to have any OSHA complaints.
So I just wanted to give the context that Andrew Grimshaw just gave, right? Which is there was a very nice panel we had a year ago. I think the video is actually online, right? So people can look at that when they get a chance. But I wanted to, I got built in there by accident somehow. I wanted to just say 2 things, right? The first is that people often look at sustainability as a challenge, right? An environmental challenge and getting to the power as a challenge. And what we've learned over the last 5 years of studying this problem is that actually there's an opportunity for greater capacity, lower cost HPC, right? If you actually think about these things in the right way. And the basic idea is that if you flex with the grid, it will allow you to access low cost, low carbon power. That'll improve your sustainability, that'll allow you to manage your power costs, and you can achieve, as we showed in this paper published in 2018, both higher throughput and higher capability for your HPC kind of workload. So that's the first thing. This doesn't have to be a downer, it doesn't have to be a restriction, it doesn't have to be a more expensive proposition. And all of the macro grid trends are going this way. And by the way, the grids need us to do this, so it's all win-win-win. The second thing is that once you start to do this, it exposes a bunch of other really interesting problems, which is you have to schedule workloads in the presence of variable carbon and power price, which means variable capacity for your data center. So we're used to these nice, stable 5 nines kinds of operation, but if you're looking at something where you're flexing relative to price, and here's an example of prices from the MISO power grid, which is the power grid in the middle of the United States, you'll get a resulting resource capacity that goes up and down with time if you're optimizing for power price. So there's all kinds of interesting scheduling challenges, workload challenges, to deal with, to overcome variation, job failures, and optimize all that for what we all want, which is high capacity or throughput for our data centers. So I think there's some interesting technical challenge, but there's also opportunity here, and I wanted to start on that opportunity.
Okay. So, Jay.
All right, I have a little bit of an animated slide, so I'm going to drive it. You on there? Yes. So I'm Jay Boisseau. I'm an HPC and AI technology strategist at Dell. I've been doing things with Dell for about 7 or 8 years. Before that, 20 plus years in academic supercomputing, running large systems, trying to get PUEs down, trying to make data centers more efficient, picking efficient components for these systems, but have a different perspective, or I should say an expanded perspective now that I'm at Dell. And one thing that I will brag about on us is from Michael Dell down, we really have a strong focus on social impact. So sustainability and climate issues are part of that, but there is an extensive set of social impact goals that the company has. The ones that are relevant to today, I just pulled out a couple of them. We've made strong commitments in terms of, on the sustainability side, in terms of recycling or reusing one product for every product we sell by 2030. And then by 2050, net zero on greenhouse gas emissions. So trying to reduce our carbon footprint, trying to reduce our waste impact, et cetera. So that's all very important, but one of the things that excites me, I assume Andrew's going to talk about what his company does, is I spent years and years trying to figure out how to build a power efficient system and then a data center where I could get the PUE from 1.3 to 1.2 or 1.2 to 1.1, and yet it was in Texas. It was all fossil-based fuels anyway, so I really need to address the 1.0 with sustainable energy at some point, and that's one of the reasons that I'm here and agreed to do this BoF, because I like what Lancium is doing there. I think at Dell we have a couple of interesting opportunities for that. Some relatively new announcements. You probably think of us as folks that make servers. We're #1 in the world in that. You probably think of us that make enterprise storage, #1 in the world in that too, and in many other categories. But we have not been an innovator in delivery models. Everything we have done has been on-prem or through some partner in a colo facility. We're taking a more proactive approach on that going forward. Apex is a big initiative in which we can provide managed services, okay, on-prem as well, but in professionally managed, highly efficient data centers. And those data centers, there's a lot of room for where future ones could be and what the energy mix or the energy mix might be for those. The other is one that I actually created, HPC on demand. It's our true cloud model for HPC. Again, that could be anywhere. And I think at Dell we really need to focus on where we build that out. We have 256 nodes now in the Switch data center in Las Vegas, and it says it uses 100% renewables, more hydroelectric there. But as we all know, energy credits are not always a conserved quantity. Sometimes it's more of a marketing move, et cetera. So you want to make sure you're in a data center that is actually using clean energy as much as possible, and that's why this BoF excites me, and I'm hopeful to get ideas from you that I can take back to our team on Apex and HPC on demand and figure out how Dell can not only deliver great HPC, but deliver carbon neutral HPC in time.
The hook's coming out. What? The hook's coming out. Vincent, I'm done.
Right. Hi, my name is Vincent Lim. I'm from the National Supercomputing Center of Singapore. In Singapore, the situation is a bit unique. We only have one grid, so we don't have much of a choice in the choice of a power that is being provided. But however, we do try to make changes for climate change. The latest supercomputer that we have installed, we are hoping to push PUE down to about 1.1. That would be the most ideal situation. Our government has also highly encouraged the industry to produce better data centers. unfortunately in Asia it's challenging for us because the climate, the humidity is so much different from the rest of the world. We have high humidity, we have high heat. You know, it's always been a challenge to keep things cool. So I guess one of the things that I would like to hear, you know, from the rest of you is if there's any other ideas or opportunities that we can use, you know, within our region to better ourselves, you know, and get better energy efficiency from the system. Of course, we are also looking at decarbonizing as much as possible. So we are looking into be it our supplier, the systems, the way we build data centers, what green materials we are using. We're trying to bring down the carbon use as much as we can. Of course, we are open to looking at any other countries that have you know, net zero or zero carbon data centers, you know, where we can actually host. Of course, I think the most challenging thing about that is to get through the data sovereignty issue. I guess it's the same for most people here in most countries. We are trying our best. We hope to achieve that, you know, with the rest of the world. Well, that's all for me.
Okay. So, Dieter.
Okay. Hello, everybody. So one thing Andrew didn't tell is he also asked us to be provocative and controversial. And those people knowing me this is very hard for me, very difficult. Okay, so let me start with a quote from my PhD advisor. He always used to say, we did that 10 years, 20 years, 30 years ago, what's new? And actually, that's exactly the story I wanted to give you. 10 years ago, we started to build a Supercomputing, our first hot water cooled system. And we did a couple of things at that point, I think, which are still relevant today. First one is we went 100% renewable energy. So we are buying only renewable and it's certified what's going in. Second thing, the system itself, as we all know, these computers are just heaters, which by the way also do some computation. Yeah? But in principle, the difficulty is always how to deal with the heat. And I mentioned already, we do hot water cooling. We started with Supercomputing in 2012 with 35 degrees Celsius. Today we can do that with up to 45 degrees Celsius warm inlet water. And that allows us to really cool the system with just using free cooling throughout the year. Not in Singapore probably, but in where we live. Yeah?
Well, if we want to be controversial, I actually think that's the wrong idea.
Well, let's see. Let me get back to that.
Well, I just raised the flag.
That's what you wanted, no?
Yeah.
The surprising thing is that we are using 40 degrees in, 45 degrees out water.
Yeah, that's. But let me finish first, okay? So the next thing is we also changed the procurement way. The procurement was. Are you coming with the book already? No. Good. So the procurement principle that we do is we use total cost of ownership. So we buy a system as big as possible, and the remaining money needs to be there for all the energy costs that we have. Yeah? So in total, you cannot build a system that is too big because you will not suffice with the energy costs. And that was also a useful thing. And then over all these years recently, we did some more things like dynamic frequency scaling. Yeah? So most of your systems, I would guess, are running with 100% clock, the nominal clock frequency. We're running with an average of 69 to 70% clock frequency. And again, we're saving energy in that one. Yeah? So in the end, what we have is a system that really has a PoE of 1.06, and Michael is looking very careful because he does not agree to this number, but 1.06 means that 6% is the extra energy we need to cool the system more or less. And I think that's a fantastic value, and that also means we are really kind of very nice to the climate.
Okay. Alan? Alan asked me to put that up. So.
All right, so that's actually a perfect segue, and I want to call you to action. As Dieter said, we've been doing some things for a long time. However, we have not been terribly coherent about getting people to pick them up and take them along. Now, we have a lot of methods of doing that in software development, hardware development. We're good at sharing information, but we aren't so good at writing down what we're doing about reducing HPC's carbon footprint. Many of us do things. So this is an effort. This is actually probably the fourth workshop we've run. This workshop will be at the Utility and Cloud Computing and Big Data Computing Applications and Technology Conference. If you want to find this page, look for DAAC-workshop.org, DACworkshop.org. It's actually the 5th in the series of DAC, Data Center and Automation Analytics and Control workshops. This is going to be focused on producing a document that will be the best community assembled reference information on what to do. And I want you to participate. The workshop will be open to remote participation. There will be an hour-and-a-half period during the conference where we'll be assigning people editing tasks, and the outcome of which will be a document that you can read and contribute to online, just like you contribute to a GitHub repository.
Okay, thank you. So Satoshi Matsuoka, who I don't think needs an introduction from me, is next, and he wanted me to put up a different website.
Yeah. I'm Satoshi, and yeah.
I'm trying to find it.
Yeah.
Oh, I know where it is. Yeah. This was what we call in the office of Grimshaw.
Not that one. No.
I'm in the wrong place. This is why I don't.
Not powerful. All right, so and the screen is off.
Screen is off.
Somehow it's off.
Well, I'm gonna do what we always do with Microsoft. I'm gonna plug it back in.
Yeah. Did it work?
Well, it's pretending it did.
There it is.
Okay.
Okay.
Right, so what I'm showing you, and you can access this online, it's a dashboard, it's Fugaku's dashboard. Has lots of stat if you're interested in how Fugaku is doing, you can access that. And in particular, we reorganized dashboards so we have the power numbers way up front, okay? And and you know, there's been electricity crisis everywhere, and we've been hit with this soaring power bills. And we learned several things, and I'll tell you what we learned. And this reducing carbon footprint in HPC is not as trivial as people may think. So firstly, we had a previous machine, K Compute, right? And then we had Fugaku. How much improvement have we made over this 10-year lifespan from going from like K to Fugaku? Okay. So you see here, you can read the small fine print. Right now, Fugaku is using about 16 megawatts. Okay. How much did K use? About 12, 13 megawatts. So there was a very nominal increase in power from going from K to Fugaku. Initially, when we were designing the machine, we were telling government we're going to about 2 or 3 times more power, use more power. And you know, and by the way, metrics like GreenCon 500 has no meaning, right? Because it's based on HPL. What's real here is we have a machine that's 160,000 nodes using 16 megawatts. Divide 16 megawatts by 160,000, what's that? 100 watts per node. 100 watts per node. And this is HBM enabled 48 core, full-fledged ARM core. And you can see that in these numbers. These 93.1, 98.6, these are the actual power usage by each of the nodes depending on their power. 100 watts per node. Including network, and including the power supply overhead, including AOCs. That's how low power these machines are. So we made some, how powerful is K compared to K computer? Almost by 2 orders of magnitude. So over the 10-year lifespan, we improved the power efficiency of the machine by almost 2 orders of magnitude, by a factor of 50. How much did Google improve over the past 10 years? They published the numbers, factor of 5. So HPC, was just an exemplar. So HPC has made enormous progress in terms of power efficiency to bring the carbon footprint down. The only problem is the more we provide, people use them. Okay? People keep using them because as you can see here, if you look at the other parts of the dashboard, the machine is full. Right? Despite the fact that the machine has 50 to 100 times powerful, the machine is still very full because people have workloads that fulfill these machines. What are the other things we have learned? Well, so start with 8 times. Yeah, just wanted to get this point across. So, over the past several months, we have had some, like I said, real crisis in terms of power. And you can see that if you manipulate this dashboard like that. Here's over. Okay. Oh, okay. So we see this is this is like January 1st to November, the date we have today. You see this downswing in power. What's that? Well, that's when we have to turn off 30% of the nodes because we were facing financial crisis due to this sudden surge in the in electricity prices caused by various things that we all know very well. So we turned off 30% because because RIKEN will basically have to go beyond our budget. We couldn't do that. So we did all those power saving measures. We turned on all the power saving measures to the max. But in the end, we have to turn off 30% of the nodes for a certain period in order to compensate. Of course, that was good. Right? And it's very similar to the variable power supply from the grid situation. Is it beneficial? Well, it saved us some money. Of course, it saved us carbon footprint. But in terms of the opportunity cost, how much is Fugaku per year? It's about $200 million per year. It's $1 billion machine, and there's overhead about $200 million. How much is our electricity bill, even at this peak? About $40 million. So the CapEx versus OpEx, if we turn off the machine, we're losing in terms of the CapEx. So the OpEx, we really have to be cognizant of balancing the opportunity costs versus, and that also includes running machines slower. Because when you look at the various power modes here, well, we advise the people on Fugaku, people can set different power modes. Okay, so they can, there are different types of power modes that people can set, and some power modes save more power than the others, depending on the application. But we also advise the users set the power modes so that you get minimal power, but you don't sacrifice your runtime. Because if you sacrifice your runtime, you use more energy as a result. So don't do that. Okay, we advise people benchmark your applications. Don't lose your time. Okay. So that's what we advise people. And so this again, it's really a delicate balance as to how to incentivize people, not and also to run the system to the extent that we are not sacrificing the CapEx portion over a data center, because that's a lost opportunity.
You wrapped up.
So the final thing. So how do we incentivize people to save power further, despite this? So from starting next year, we plan on allocating people energy instead of runtime hours, so that it'll incentivize people to maximize their energy, their power, maximize their runtime, whilst minimizing the power usage.
I think that's the wrong idea.
We'll get to that. Thank you very much. So those of you who are old enough to remember Monty Python, now for something completely different. I'm going to give a really different perspective. We've heard a lot here about PUE, increasing efficiency, watching how many watts you use, and all of that kind of stuff. And what I want to do is to take a different perspective. And so at Lancium, and I've got to keep to my own rule, okay? At Lancium, I heard all this and I'm thinking to myself, wow, that's weird, because we're building data centers essentially in renewable-rich environments, where we operate in 3 power regimes. I didn't have this on my slide, this is a response to what's going on. In 3 power regimes. In one power regime, the renewables are producing. And at that point, the energy, 15% of the time in the Texas West load zone, energy is negatively priced. Think about that. They pay you to use energy, okay? Second, 80% of the time, the cost of the energy is below the cost of the natural gas used to produce it. So pretty much the nat gas gens, there's a few exceptions, are completely out of the equation at this point, and it's all renewable. It's only in the last 5% of the power cost curve where power costs are going really up that we get out. And then the reason is simple, right? At that point, the grid is stressed. That's why power prices are high. The renewables aren't generating, and that's where power efficiency matters. And so, to me, efficiency is not that big a thing. When I started at Lancium, our CEO Michael told me, consider electricity free. That is a totally different design constraint that I've lived under my entire life. The wind and the solar now, I'm going to kind of fly through this, are the cheapest way to produce electricity in the world. And they have two big problems if you want to address them. Since this is not about power costs, this is really a session about carbon. I'm going to focus on the carbon aspects. But there's two problems with renewables. They're variable and they get congested, which is a fancy way of saying that there's power generation, but you can't get it to the loads. Okay? And so the thesis of what we're doing in Lancium Compute is if we want to do low carbon, very low or zero carbon computing, and be really inexpensive, we need to move computing to the load. Because computing, all of us know that all we need for computing is pinning and power, networking and power. And the power out there is incredibly cheap. So we're well suited to do that in HPC because, believe it or not, you may not think this, but we have loads that we can pause. And when they're paused, the power level will drop. Almost all, not all, HPC applications are batch and typically don't have a human in the loop, which means if you stop it for 20 minutes, at the end of the day, nobody will really know, right? That's one of my components. So what we've done is we tried to flip the perspective, sort of as Andrew was talking about earlier. Rather than have the grid adapt to the data center's 4, 5, 9 requirements, we're going to have the data center have a 1.9 power, 1.9 by the way, is really easy to achieve, environment. But what it will let us do is get cheap to free power and have it be non-polluting. So finally, and this gets to, we've been using these metrics in the community at least the last 10 or 15 years of power efficiency and flops per watt. Now here's my provocative statement. Flops per watt isn't the right metric. Because if watts are free, including carbon free, why focus on that, okay? What we really care about is flops per dollar, power is our problem, or flops per kilogram of CO2, if we're concerned about that. So I would argue that's what we should be focusing on is, flops per watt was really a proxy for what we were really caring about, which was CO2 or energy cost. So let's focus on the things we really care about and move forward. And with that, what we're going to do,
I need to say something on that.
now we're in free-for-all mode.
Okay. Then it's free for all.
Just give the audience a chance to weigh in.
No, I need to say something as a follow-on to what Andrew said. So I think there are two things that are true. The first is that this notion of a stranded power or excess renewable power is much more widespread than West Texas.
Yes.
Right, and we've been doing studies that are across the United States, and there are other folks who have been doing studies around the world. So don't think it doesn't exist in your geo. It does exist in your geo, and it's growing fast, right? So that's the first point I want to make. The second is we have a bunch of published studies that document this as a real dynamic quantity, which support the kinds of things Andrew's saying. And I met Michael, right, back in 2018, and he came and he started talking about the ideas behind Lancium. And there's a remarkable amount of synergy with the zero carbon cloud vision that we had. And it's, I think it's fantastic for me to see at least what Andrew and Michael and the whole Lancium team is doing. So, but I think it's a much broader opportunity than, with no disrespect, than just West Texas and what Lancium's doing.
I agree 100%. I mean, in Germany, for example, I've talked to a lot of people, and you can correct me if I'm wrong here, but they have a lot of wind power up near the North Sea, but a lot of their load is down in the south. And the problem is, they can't get the power from the north to the south. In the United States, we think we have problems with building transmission lines because there's a knot in my backyard syndrome. In Europe, in Germany, they take that to the extreme case. I mean, I'm not
Not in my backyard.
Yeah, exactly. They don't want anything, right? They want the results, but they don't want to price, basically. So anyway, what we want to do is have people talk, say something, ask a question, and Jessica's going to write it down. Can you guys kind of come out and sit here? Let's do that.
I want to ask the audience a question. How many people run or contribute to running a supercomputing center? Very large fraction. Of those, how many have their supercomputing center 100% occupied by only FBI jobs?
Nobody.
Okay, if you had the opportunity, this will be the last question I ask, to move the small core count checkpointable jobs to another clean energy facility and free up your supercomputer, how many would take that opportunity?
Nobody.
Nobody?
That's really interesting.
That's like getting free cores, right?
I was just sitting by a hydroelectric plant, so.
And so you're already doing
Whatever
it?
you're talking
Yeah.
about, we're doing that.
So, that's great, you just need to contribute to our DAC workshop.
I have another comment back to the transmission lines. One of the big problems is that computing has been so exciting, and computing engineering, the hardware side, for so long, that's where all the students went. And it's been hard to get people to study batteries and transmission lines. And somehow we have to tell people that power generation and power transmission are important enough that there will be jobs.
Yeah,
But that's a different.
I'd like to respond to that because there's two separate problems. There's congestion, which is transmission lines, and that's just going to be hard to solve. I've been telling students, I'm now retired by the way, that material science is a thing you should be getting into because right now there's going to be an explosion in work on energy storage devices. I don't want to call them batteries because people think of lithium when you say battery. And there's a lot of really exciting work going on. The challenge is that to get the manufacturing scaled up to the level where you can do grid scale energy storage, a gigawatt hour is a lot of energy. If you're the state of Texas and you use between 40 and 60 or 70 gigawatts and you want to store solar power over the day, that's tens or hundreds of gigawatt hours. So it's going to be a long time getting there.
And so when we started studying stranded power or this negative price power, we asked that same question. We said, well, is energy storage going to get so cheap, right, that it's going to eliminate this? It turns out that it cannot get cheap enough for it to eliminate this. It turns out that the reason we have this free energy or this fluctuation has to do with statistical variation in generation. So it's uneconomic to place enough storage in the grid in enough places to ever eliminate this. That's why we continue to work on this area. But I did want to just sort of twist this in another direction because Andrew pointed us in this direction. Several people were very proud of the fact they were able to drive down their PUE by using hot water cooling, right? I think that was a good idea. I think it's the wrong idea going into this world. Let me explain why. Because the idea here is that what you want to be able to do is to flex up and flex down, right? Your capacity. If you want to flex up, what you want to do is increase your heat carrying capacity out of the building. The way you increase the heat carrying capacity out of the building is by dropping the temperature of the water and increasing the flow rate, both of which increase PUE. But you're willing to do this because you have low price power and low carbon power, right? So the point is that static operating point is the wrong static operating point, right, to think about this new world. So we wrote a paper, for example, that was in hot carbon this summer, this using hot carbon this summer. Forgive me, I'm an academic, I have to plug my work. But it doesn't solve any of these problems, but it points out there's 3 or 4 different ways we've been thinking about it wrong if we're trying to design data centers that can flex up and down with, as Satoshi said, low capex.
Yeah. By the way, we don't use hot water cooling, but we use very high flow rate. PUE is 1.1.
Maybe back.
Oh no, we
You're
use
gonna have
high
to shout.
flow rates.
I can shout.
Pardon?
My question is regarding Dell.
That's pretty high.
So
High pressure water.
before I did any kind of HPC or sorry, before this does not work.
Just shout.
Before I did HPC, I did regular IT as a technician who unloaded monitors, lots and lots of styrofoam. Y'all still use it, and now I'm doing servers, and it's still friggin' styrofoam. There are other options. Please use them for fire trucks.
It was embedded in hard to read text from the back of the room on that slide, but we actually have goals for turning 100% of our packing materials to recyclable by 2030. So I realize it's 2022 right now, and I have been where you are. I have unloaded thousands of nodes of Dell gear in the distant past in a different role and wondered why they had to print a manual for each one of them. And other things like that. We are working on simplified packaging and recyclable packaging, and it'll be 100% recyclable by 2030.
I mean, I really suggest the mushroom stuff, for styrofoam replacement.
Do you want to mention CEP, Circular Electronics Partnership? That's one of the Circular Electronics Partnership, that's one of the big things.
I don't know enough about it to mention it, maybe you should.
Okay, well, so there's a big partner industry-wide consortium called the Circular Electronics Partnership. Dell is one of the leaders, but there are a number of other leading companies, and their goal, as Jay alluded to, is to create a more modular kind of hardware ecosystem where systems are designed to be demanufactured, perhaps repurposed, and so on, to deal with both the embodied carbon as well as the e-waste kinds of aspects that our industry has.
Yeah, I almost put a picture up of Project Luna. I didn't because this is an HPC crowd and Luna is a laptop. But the idea is it's all modular and you can just, if you need a new display, recycle your old display, put a new higher res display on there.
And there's open compute projects as well.
Can we have somebody else have a question? Go ahead. Gentleman there. Shout.
So I love Satoshi's idea of an energy budget for computing. I think that's a great direction to go. It's something we're thinking about too. We've been talking a lot about energy, but because this is about carbon, maybe this is slightly controversial, but have we considered the embodied carbon in building these systems? As an arms race, where one country has an exaflop system, another country says, hey, we'll build a bigger one. Country A says, hey, next year we need a bigger one to beat them off of the top 500.
So what are countries A and B?
It's a good question, but I want to point out.
Increase the lifetime of these large systems.
Yeah, I want to point out that, and that's a good point too, Andrew has a lot to say on this subject. HPC is a tiny fraction of computing, but we are the laggards in coming to address the carbon footprints. The big cloud providers already do this. They already, for decades, have been building their systems where power is cheap and lately where it's green. And by the way, Dieter, I will push back on you a little bit. You may have a contract that says you're buying 100% renewable energy, but as far as I know, Lumi is the only supercomputer on at least the top portions of the top 500 that's actually 100% powered by renewable energy. But so there are aspects of what you say that are correct, but I think we should look at behaviors that we can take that will lower our carbon footprint. So I'll go back to the question that I asked. If we invented 20 years ago this thing called the grid, where we can move jobs flexibly. It actually runs now. The European Open Science Grid, the Asia Pacific Grid, Open Science Grid in the US. I said European Open Science Grid, I meant cloud. It's now the European Open Science Cloud. We're bridge technologies with these things. We have the ability to move jobs. We can set up a situation now with existing technologies. In fact, we do it all the time, where you migrate jobs to where the compute is available. Why not do it so that we migrate jobs to where the compute is available with low carbon load?
Okay, let's do one more question. Oh boy, we have multiple ones. This is tough.
We've got the going.
Topic's hot.
Now I have to play favorites. I think the gentleman in the back raised his hand first, all the way. That's beard, dark hair, top. I think it's called the top knot. I'm not sure they work.
Is it working?
Yes. Yeah.
Okay, thanks a lot. We mentioned several levers to reduce the carbon footprint, maybe the main one being using renewables. But of course, renewables does have as well like a non-neutral carbon footprint because you need to build these solar panels, etc. So I guess my question would be, what would be the next step? Let's say all supercomputers run on renewables energy. What would be the next step to keep improving and reducing the carbon footprint?
So I'm going to say one short thing. I mean, an idea Andrew came up with a long time ago is let's extend the lifetime of these machines. Let's not throw them in the dumpster every 5 years.
That's what I was referring to.
For starters. But I mean, it's always going to take, won't always take carbon to manufacture things. I mean, they're already starting to look at replacing carbon in many manufacturing processes, including steel, using hydrogen for that. Assuming you can get clean hydrogen, there'll be a lot. I'm not as depressed about the future as I used to be in terms of all that kind of stuff. But yeah, you're not going to solve the problem in 1 day or 2 days or even 3 days. It's all drops in the bucket.
Well, and I was going to add, you already answered your own question. I mean, the answer is you go down the cycle. You use renewable energy to create the renewable energy generation things that you need to do. And that's actually one area where wind is actually superior than photovoltaic to solar generation. Actually, the payback period for the wind manufacturing is much shorter than for the solar.
I think we got time for one more gentleman there. We'll do two more and then we'll get you. This is a great topic, I'm glad, but we're gonna throw us out of here in just a few minutes.
They are? It's not even 1.
1:15.
First of all, I think
1:15. Chill out, dude. Chillax.
okay. So Svein from Green Mountain. First, I'm going to correct you, Alan. I think there's several data centers who actually have carbon negative or carbon neutral data center providers for.
In the top 500, Lumi is number 5.
Yeah, but let's say you have multiple European clients who have their data centers, for instance, in the Nordics.
Keep doing that.
Secondly, to answer your question, I think the next step now is heat reuse. So the ability to actually leverage the heat from the data centers, and we have Eco Data Center there from Sweden and ourselves from Norway. We have that opportunity to do that. So I think that's one of the things that you can do. But one of the things that amazes me is your first question. Why don't you move workloads that doesn't need to reside in areas where you have high carbon or energy? Because there's really no reason why this data should reside in locations where you're not able to. Supercomputing environments, it's you can have high latency on those workloads. It doesn't need to reside very close to you, at least for a lot of those workloads. So I'm just amazed that people don't think about those options of moving those workloads to areas where you can actually get good renewable options.
Okay, so real quick,
all three of us want to.
Q-Scale is a company that came to our last DAC workshop to talk about the facility that's near completion now in Quebec, where they use the heat. It's an interesting application of what you just said. They use the heat from the computers to do agriculture in Canada. So that's an example of what
similar
you
thing.
We do it to farm lobsters and.
It's not cogeneration. This is a thermal.
Right. Thermal reuse is great, and actually, at our sites, we're going to be doing hydrogen as well. And it turns out if you preheat the water going in, the efficiency of the electrolyzers is much higher, and so it's a kind of a win-win. But I know Dieter really wants to say something.
Well, I want to continue passion in German.
Okay.
We wanted to use the heat from the system just for heating. Yeah, it's very simple, straightforward thing. And we wanted to do this for 10 years, and nobody wanted to take the heat because it's too much effort. You need to connect it to the loops and so on. Just to say, today with the strange global situation, suddenly they want our heat. And it's pretty easy to just heat up a number of 100 buildings kind of with what we get from the heat. Yeah? And you see how stupid it is. We could have done that years ago.
So what reliability guarantee do they want?
Sorry?
What reliability guarantee do they want?
They have
Are you allowed to turn off your computer anymore?
There is a heating cycle anyway, yeah?
Yeah.
So we're just contributing for them to use less other energy sources. See, it's as simple as that. And we're heating for years. All these systems are heaters, as I said. And we just need to, I'm not sure, Lumi, Kimo was here somewhere. I'm not sure if Lumi is very useful because there's no people living around Lumi. So what would you heat, yeah? Sorry for the Scandinavian.
I think that's a very, very good thing actually, the ability to create those business cases that creates value for taking the heat.
There'll be a brawl outside right after.
I couldn't even make a business case because if I would sell it, if I would give it for free, I would have to pay taxes. That's how stupid bureaucratic is, yeah?
Just that what we did is that we created a business case for our local lobster farm.
Oh, that's a cool one, yeah?
So by reducing the time that a lobster needs to get to market.
But we need more ideas like that, yeah?
It pays for itself.
Okay, so, lady over there. Oh,
I
wait.
do have one comment. I think the gentleman there is right. You don't need to sit beside it, to run the workloads, which is precisely what we are doing in Singapore. We are looking at the possibility of sitting these supercomputers elsewhere, because as you know, we are in a tropical environment. It's hot, it's humid. Energy cost is high. And there's really very limited things that we can do to reduce carbon in our area. Now, sitting it elsewhere is one way to go. The only issues that we have is always with data sovereignty. It's the problem between countries. This needs to be sorted out before I think this can be something viable for the rest of us.
I keep hearing that too, and unfortunately, it's above our pay grade. You know,
But
and,
it
we
has
have to
to
try to
happen somewhere.
influence the people above
You
our
know,
pay grades.
it has to be
smart.
feedback to the government to do something, or else it's never going to change.
Yes, ma'am.
Hi, my name is Natalie Bates, and I chair the Energy Efficient High Performance Computing Working Group. I know a lot of you. I encourage all of you to participate. First of all, thank you very much, everybody, for doing a great job. This is a really important topic. I do want to shamelessly advertise that we have a BoF tonight on software and energy efficiency. We have a BoF tomorrow, actually the same topic, except for we've got lower level people. Sorry, you guys. We actually want to try and get some work done, share what we're already doing within sites, and try and figure out what kinds of things we might be able to do moving forward to work on carbon neutrality. Tomorrow night we have a BoF for anybody who's still air cooled, who's interested in liquid cooling. We have a BoF tomorrow night on liquid cooling. It's a how-to, right? So it's got a whole lot of people who've got tons of experience with liquid cooling going to be available to come and talk to you about little things that you can do to start deploying liquid cooling in your data centers, because that makes a huge difference. We also have the Green 500 BoF. We've got some people there. We're working on a new version of the power measurement methodology. And so we're going to be reporting on that at the Green 500 BoF. And then Thursday, Michael, you want to stand up? Michael Ott and Jeff Hansen, actually, and Norm are all going to be leading a BoF on operational data analytics, which is, really key, collecting a ton of data. And then Friday, Dieter and Satoshi and a couple other people are participating in a panel. The panel is going to be on disaster management, right? Climate change is causing a whole lot of unexpected things that we need to start planning for. And so we've got a panel on Friday. Dan Reed's the moderator, and it's going to be on disaster management. So I hope those people who do stick around to Friday morning are able to go to that too.
Any other questions, comments, or inflammatory statements from the audience? Yes? Yeah? Can you pass yours? It's hard to hear. Can you use the mic?
Yeah, thanks a lot. So nearly all of you were mentioning the POE to somehow rank how efficient a data center or HPC can be. Is this really the real number we should consider if we're thinking about carbon neutrality? There's one thing, a data center can be big or small, can be using heat or not, can be coming from renewable energy or not. Should there not be something like a standard which can rank maybe nationwide or even worldwide, where I can directly see, okay, this HPC I'm doing here is efficient and sustainable, this one is not? Or are there some ideas in this direction?
So I'll quote my colleague at Texas Tech, Catherine Hayhoe, who's now chief scientist at the Nature Conservancy. Every little thing you can do to help helps. Okay, so yes, if writing down these kinds of information will help people make decisions, we should do it. If you can find a way to alter the incentives to your user base, do it. Every little bit that you can do to help will help.
Is that a question or is that related to this?
Yeah,
because these guys want to talk. Yeah.
So, yeah, I agree with that, and I tried to make that point in my opening statement. I mean, I was the guy that always worried about PUE, and I did it for a good reason. My metric there was all my power is carbon-based, so I wanted to use as little extra power as possible doing it. But as I tried to get to, and Andrew said really better, if you can go to carbon neutral sources, then that shouldn't be your measure at all. And you might say, well, what about in between? I'd really much rather see a metric that is carbon efficiency than PUE. Maybe you have a mix of energy sources over the course of a year. How much carbon is your 100 petaflop system actually putting back out?
I was going to point out that one of the, arguably progress directions that's happening is the European Union is now requiring all corporations to report on their GHG emissions. So that's forced all the cloud companies to now begin to actually, if you do computing at Google or Amazon, they'll give you a statement at the end of the year that says this is your GHG impact from those computing services. Could our centers do the same? That would be a way to make this accountability.
Satoshi, and then we'll go back to the audience.
Yeah. So. PUE may not be the best metric, and totally agree. Of course, having PUE 2 is bad. But having 1.1, 1.15 is a very minute difference. What I like to point out is even accept the fact they may have some some renewables which will make you essentially almost carbon free. Then you need carbon to manufacture the servers and so forth. So ultimately, for the infrastructure you have, you have certain capabilities, and your carbon workload, carbon load is measured against that, no matter what you do. It will either be the CapEx level or the OpEx level. So then you need performance per whatever carbon emission you emitted, which is in some cases is like clocks a watt or something like that, or it can be something else. But you really need to measure your carbon emission or your wattage or whatever against your performance, and people don't do that. Even Green 500 is a broken metric, right? Because it's as much as we excel at that.
Okay, I'm gonna be the moderator because we're running out of time.
Yeah. So we need we really need to have metrics of a variable workload, varying workloads, and mandate all the benchmarks or whatever the operations to record these measures, and not just rely on single metrics like that we.
Right. These two gentlemen have been hopping to say something, so we'll get that, and then we're going to wrap it up. Okay.
So the direct answer to your PUE question is in the United States, the Department of Energy released in December 2021 the Executive Order 14057 that we created, and all federal facilities are going to be moving to the family of Green Grid. So not just PUE, all of them. There's carbon use efficacy, ITUE, the whole thing for all federal facilities. Tomorrow in the BoF that Natalie mentioned, Steve Bruno from the DOE Federal Energy Management Program will be discussing that. So there is movement in the US towards better metrics. Because PUE is heavily skewed towards larger facilities, which get better numbers.
Last audience thing, can you get that to him?
Yeah.
And then we're going to wrap up.
Do you think it could be useful also to ask in our public procurement to ask to the vendor to have some data on the performance of the carbon footprint production of their system? Because if we don't ask that in our public procurement, well, the vendor will not produce the data, will not look at that data, and so I think maybe having that as one of the criterion on our public procurement, especially when we are going to exascale. Do you think that could be something useful to go further?
That's something you're thinking in your requirement. Go ahead. You want to answer that?
Actually, I was going to say, if you look at where the major foundries and fabs are in the world, you'll find that that kind of criteria is going to produce a hugely prejudicial kind of landscape. And I would question actually whether people are willing to face up to that, right? Because the landscape is very skewed for embodied carbon.
Okay, so as the session organizer, one of the things you always fear in a BoF is an audience that doesn't say anything. And so I'd like to start. What?
Problem solved.
Yeah, I'd like to start by thanking the audience. The panel as well. And so let's, solve the problem. We're engineers, that's what we do, right? So let's go, have a good time, and we're done on time.